This short video is to talk about the prime number theorem. The prime number theorem talks about how many primes are there up to some value. So how many primes are there less than a million, how many primes less than a trillion, and so on. And so while there's no formula that we know of that can give you the exact number of primes less than or equal to a million or a billion, or any number, what there is there's asymptotics. And what I mean by that is if you were to look at the limit of pi of x over x divided by the natural log of x divided by the natural log of x, what this is this limit is 1 as x goes to infinity. So what this says is that when x is large, the number of primes less than or equal to, say, a trillion will be approximately equal to a trillion over the natural log of a trillion. So just as a little bit of comparison, let's use a trillion. Let's look at 10 trillion. So 1,000, million, billion, trillion. So that's 10. So this is pi of 10 to the, let's see, we got 3, 6, 9, 12, 13. So this is pi of 10 trillion. And if you were to take 10 trillion and think about how many primes there are up to 10 trillion, this is a big number. This is about 346 billion. Oops. So 346 billion, 65 million, 536,839. And then compare that to 10 trillion divided by, so 10 to the 13, divided by the natural log of 10 to the 13. And that'll give you, so 10 to the 13 divided by the natural log of 10 to the 13 gives you 334 billion, 72 million, 678,387. Okay, so not exactly the right amount, but this is pretty close. And actually, if you were to take the ratio of these two, so if you were to take the ratio, if you were to take, say, pi of 10 to the 13, so the number of primes, the actual count of primes up to 10 to the 13, divided by 10 to the 13 over the natural log of 10 to the 13, what you'd end up with, you would end up with a number that's roughly 1.034. And this number gets closer and closer to 1, the larger the input is. And so if you were to have 10 to the 20, this number is like 1.023. And if you have 10 to the 25, this number is like 1.018, and so on. And so computationally, that gets harder and harder to find. Clearly, finding the numerator is much harder than finding the denominator. But that's the point, is that even though the numerator is hard to find, you can still estimate the numerator with the denominator. Okay, and so that's called the prime number theorem. This gives us an approximate number of primes less than or equal to some value x.